application is called Newton's law of cooling. And so this just simply reads if D sub 0 is the initial temperature difference between an object and its surroundings, and if its surroundings have temperature T sub S, then the temperature of an object at time t is modeled by the function T of t is equal to T sub S plus D sub 0 times Euler's number raised to the negative kt, where k is a positive constant that depends on the type of object. Now, this formula looks intimidating, but it's really not that bad. Let's take a look at an example. So a cup of coffee has a temperature of 200 degrees Fahrenheit and is placed in a room that has a temperature of 70 degrees Fahrenheit. After 10 minutes, the temperature of the coffee is 150 degrees Fahrenheit. A, find a function that models the temperature of the coffee at time t. B, when will the coffee have cooled to 100 degrees Fahrenheit? So to answer A, notice that in our description of our problem, the only thing we're missing is K. But they do give us enough information to find K because they also tell us after 10 minutes the coffee is 150 degrees Fahrenheit. So to come up with a function for part A, we first need to figure out a value for K. So when I look at a problem like this, the first thing I want to do is identify the information within the problem. So it tells us the cup of coffee has a temperature of 200 degrees Fahrenheit. So that's going to be our initial temperature. So I'm going to say temperature at time 0, which is not something we actually use in the problem, but it's good to note that that's the temperature at time 0. Our temperature of our surrounding conditions, it tells us, are 70 degrees. This we do use in the actual equation. And then we need to know our initial temperature difference. So that is the difference in the temperature of the object and the surrounding temperature at time 0. That's what the little subscript of 0 means. It just means at time 0. So if I take 200 minus 70, our initial temperature difference is 130. Now, the other piece of information they tell us is the temperature after 10 minutes is equal to 150. So I'm going to go ahead and set up an equation to solve for K. And so here the T, I didn't list it, but T would be equal to 10. Let's just add that to our list so that when I fill it in, everybody knows where it's coming from. So my equation would be 150 is equal to the surrounding temperature, that's the 70 degrees, plus the initial temperature difference of 130 times Euler's number raised to the negative k, which we don't know at this point, times 10, because the 150 degrees Fahrenheit we were told happened after 10 minutes. To solve, what I would do is first I would subtract 70 because I can't add the 70 to the 130 because the 130 is being multiplied. And order of operations says that that multiplication has to come first. So I'm going to subtract 70 from both sides. And that will leave us with 80 is equal to 130. Euler's number. And I'm going to go ahead and rewrite this because k and 10 are being multiplied. So I'm going to write it as negative 10k. So my next step, I would come in and I would need to divide by 130 because I can't multiply it times Euler's number yet because I do not know k. If I knew k, then I could go ahead and evaluate. So this is going to simplify to simply 8 over 13 is equal to Euler's number raised to the negative 10k. Now, I didn't point this out in the beginning, but the objective here was to isolate the base with Euler's number. Because to be able to solve for k, I'm going to have to turn this into a logarithmic equation and solve for k. So since we're dealing with the natural base, when I change this around, we're going to change this to the natural log of 8 over 13 is equal to negative 10k. So that's going to end up giving us, and I'm just going to carry on to the next slide. It'll be all right. I'm going to need to divide both sides by negative 10. And so we'll go to our calculator here in a moment. Now, k is going to be an approximation because the natural log of 8 over 13 is an irrational number. So let's go to our calculator. And we're going to go in and find the natural log of 8 divided by 13. And then I need to divide that by negative 10. And so we come up with a k value of about 0.0486. So let's use 4 decimal places. So I'm going to say 0.0486. Now, with all of that work, we can finally answer part A to example number 1. Because what I was missing was that k value. So let's go ahead and answer part A. Let's write a function. So the temperature, let's switch back to blue. The temperature at time t, there we go. The temperature at time t will be equal to our surrounding temperature plus our initial temperature difference times Euler's number raised to the negative 0.0486, because that's our approximation for k. So for this cup of coffee, for instance, times t. And so there's our function. So you give me a time, I can tell you what temperature the cup of coffee is going to be. However, in B, they don't give us a time. They ask us how long will the coffee have cooled, or when will the coffee have cooled to 100 degrees Fahrenheit. So in this case, that means what I'm looking for here in part B is I've got to figure out a time for it. So this is our temperature at time t is what they're giving us here. So I'm going to come over here. So this is going to be part B. And I'm going to take this equation and I'm going to use it. So I'm going to say 100 is equal to 70 plus 130 times Euler's number. Let's see, I'm going to run out of room there. Oops. Let's go back. Now I got to let it reload. There we go. I just want to move this down a little bit so I don't run out of room quite so quickly. So then E is going to be raised to the negative 0.0486, and I'm still running out of room. Oh no. We're going to make it work. T. Okay. So I'm going to be carrying on the same procedure that I did on the left for A. I'm going to use the same process for solving. So what we're going to have is I'm going to subtract 70 from both sides. That's going to give us 30 is equal to 130 e raised to the negative 0.0486 t. I'm going to divide by 130. That's going to leave us with 3 over 13, at least in a simplified form. Is equal to e raised to the negative 0.0486. Oops, missed the 4 in there. 486 t. Now, I'm down to rewriting it as an exponential because I've isolated the natural base. So I'm going to have the natural log of 3 over 13 is equal to negative 0.0486 0.0486t. And so that means simply that t, the time that we're looking for here, and again, this is going to be an approximation, because number one, we approximated the constant k. So this is going to be the natural log of 3 over 13. And not only did we approximate k, the natural log of 3 over 13 is going to be an irrational number. So negative 0. And we're going to divide by this multiplier of t. And we'll get the approximate time it takes. When will that cup of coffee cool to 100 degrees Fahrenheit? So go back to our calculator, and we're going to take natural log of 3 divided by 13, divided in turn by negative 0.0486, and we get 30.17. So to answer part B, after about, and it's important that we say about because again, this is an approximation, 30.2 minutes. In other words, if we were to pour this cup of coffee in a room that was 70 degrees Fahrenheit, and the coffee was 200 degrees Fahrenheit at the time of pouring, and we were to let it sit there, the cup of coffee would reach a temperature of 100 degrees Fahrenheit after about 30.2 minutes.